Object-Oriented Software Engineering, Unit 1, Lesson 6. So we have seen in the earlier class as to how to analyze the change requirements. In the second part of the system life cycle, we see the system development and reuse. So a common desire in all development work is the ability to reuse. It should occur on several different levels of granularity. The most basic asset of software engineering is to reuse the system. Where there is no reusability, the feasibility studies will not accept the project into the organization. So we will look forward for what kind of reusability can the system give after investing so much of time and effort into the system. So a system is assembled from a set of application modules. A module in turn is composed of other modules of components. Therefore, the system developers must have access to a set of components in order to build application modules. The finest level of reuse starts with components. The object orientation gives a completely new technique that strongly supports reuse. So number one is components. Components are the already implemented units used to enhance the programming language constructs. These language constructs must be powerful, have simple well-defined interfaces, be simple to find, learn and use, and have wide area of applications. Also, it should be possible to build new components with the help of existing components. Software components are available in the form of procedures and functions for numerical and statistical applications. It is not the number of components, but the usefulness of them that determines the success of reuse. A number of micro-libraries, subroutine libraries, and so on are available for general use. Then coming to the changeable applications. An application must be designed so that it permits constant alteration. The most rational manner of building an application is to join changeable application modules which are built using the components. Modules should be chosen so that they can be combined in different configuration for different customers and in different installed systems so that the modules can be reused for different configurations in one or several systems. Also, the modules should be alterable in a straightforward manner without leading to greater cost than the size of the change. Thus, to bring the intuitive costs in agreement with the real costs. Then coming to the third point in the system life cycle, it is the reuse of other descriptions. A system consists of progress code and significant number of other documents forming the steps from requirement specification till the finished system. Apart from these documents, various forms of user-related documentation and educational material is also present. It should be possible to reuse these documents. So as we have seen earlier, we have tools, the process, the method, and also an underlying architecture. So from this figure, we understand that it is very clear that a method should be developed from the architecture. So coming to the architecture, using building construction analogy that we have already seen in the previous classes, software systems can be compared to houses. A stone house and a log house have different properties. They are built and maintained differently. However, they are sound structures. Similar differences are seen in software systems. For example, function data methods that separate data from functions. Then small changes in the format of dates will have significant consequences on the system. Object-oriented systems, on the other hand, are composed of a number of communicating and well-delimited objects. Such systems are easy to develop, understand, maintain, and modify. Therefore, object-oriented systems have important and desirable architectural properties which form the basis of the method. The architecture defines the types of models that can be built and the characteristic that each model will possess. Models of the following types may form the architecture of the system: an analysis model, a design model, an implementation model. Then comes the method. The most work descriptions for program development are method descriptions. They indicate the sequence of steps to be followed. A method is based on preconceived notion of the architecture of the working system. Description of the method is formulated in terms of concepts of the architecture to be realized. Then coming to the third one, that is the process. A process is a natural scaling up of a method. To make the method appropriate for large-scale industrial use, a process must be defined. Solutions for industrializing the laboratory method is by changing the working method so that it can be scaled up and carried out with great parallelism as a process. So coming to the difference between the method description and process description. Methods are described in a waterfall model as a step-by-step procedure with various degrees of granularity in steps. It can also be described as a system development project for one product version. It is often described as a first development project resulting in a first system version. Maintenance is an activity in waterfall model and also includes analysis of requirements, design, testing, and so on. So if you look into this figure, it is similar to the activity in the waterfall model, wherein it starts with requirements analysis, goes to the preliminary design, then the detailed design, then comes the coding, unit testing, integration testing, and also the system testing.